Hi, this is Vishal and I'm a student of Harvard Extension School and my course is Big Data Analytics and I am here for the final project for Berkeley Data Analytics Tech Emphasize on Spark. So I would like to show you the project description first. Of course, the project is about Berkeley Data Analytics Tech Emphasize on Spark. This is the website, and Spark, as it spells, it's lightning fast cluster computing. What is Spark? Spark is an open source cluster computing system that aims to make data analytics fast in both terms, fast to run and fast to write. To run programs faster, Spark provides primitive for in-memory cluster computing, like our job can load into a memory instead of a disk. So definitely it would be a faster. The Spark goals are iterative algorithms for machine learning and graphics, and interactive data mining for using Hive, Pig, Amazon EC2. Some of the advantages are here for Spark. It's open source, so it means that we can change it if we like it, and it's a cluster computing system. Make data analytics faster. Job can load in memory instead of disk. It can be up to 100 times faster. So it says up to, it means that it depends on our code and our configuration of a hardware. Often it can be 2 to 10 times less code. Spark provides easy to program interface. Spark provides clean concise API in both Scala and Java. Spark is a new engine. It can access any data source supported by Hadoop, making it easy to run over existing data. And some of the companies which are using Spark are Coniviva, Cloud and Quantified, etc. So disadvantages, it's like that right now Spark supports for this type of problems the iterative algorithms and interactive data mining only. It may happen that in future it may support some other problems. Only few people are using Spark is in a pretty new state, so pretty early stage, so means the version of Spark is 0.7.0 is the latest, so it may happen that after some time many people will be using it. Higher RAM is required for effective result. As I say, it means the processing is in memory instead of on disk, so it requires a high RAM. Previous version of Spark were not supporting all of the file systems. Right now it has extended that it supports a Hadoop file system plus some other file system like local file system, etc. Code snippets. So this is showing a code that just 5 to 6 lines of code. You can run a MapReduce job for a file of which is located into a HDFS protocol in the Hadoop environment, and it runs the MapReduce job over here. That it is developed by UC Berkeley AMP Lab, and latest version, as I said, it's Spark 0.7.0. and here if you want to contribute it and some of the references for a Spark, good to learn and good to have it. So here I would like to start now this presentation. So first of all, the agenda, we will cover something about the overview of Spark, motivation behind the Spark, how Spark works, how to run Spark, Spark abstractions, Spark frameworks, Spark examples like mining console logs and logistic regressions, and the performance of these logic regressions with the iterations of the example, and some other examples like word count and standalone job in Java, how to run Spark in EC2, and behavior with not enough RAM and memory tuning framework built on Spark applications, and the Coniviva, one of the company which is using Spark, the report of that, conclusion and references. So again, the Spark overview. The Spark is an open source cluster computing system. Spark is a new distributed programming framework for analyzing large data set. Spark is lightning faster cluster computing. It aims to make data analytics fast to run and fast to write. Spark is a MapReduce like cluster computing framework designed for low latency, iterative and interactive use from an interpreter. Spark provides clean language integrated APIs in Scala, Java, Python with a rich array of parallel operators. Spark can run on Apache Mesos Cluster Manager, Hadoop Yarn, Amazon EC2, and of course the standalone mode. Machine learning using Spark can be done with RDDs. We will talk this later about the most of the efficient thing of RDD is about data sharing, in-memory caching accelerators performance and up to 20 times faster than the Hadoop. Easy to use high-level programming interface, express complex algorithm, 100 lines of it, and it is developed by UC Berkeley MP Lab. So what was the motivation behind the Spark? One of the motivation was iterative jobs and interactive analytics. Those required repeatedly some of the data sets. So many common machine learning algorithms apply a function repeatedly to the same data sets to optimize a parameter. And in interactive analytics, when querying on a large data set, a user would be able to load a data set of interest into a memory across a number of machines and query it repeatedly. In most current framework, the only way to reuse data between computations where about a MapReduce jobs is to write to an external stable storage system like a distributed file system. This incurs the substantial overheads due to data replication, disk input-output, serialization, which can dominate application execution times. And here it's the diagram. It seems to be similar to a Hadoop input, output, map and reduce, but one more thing which flavor is added with the Spark is about having a runtime decision where to run the task, and it can automatically recover from the failure as well. So how Spark works? To run program faster, Spark provides primitive for in-memory cluster computing. Job can load data into memory instead of a disk and query it repeatedly. Spark run much more quickly than with disk-based system like Hadoop MapReduce. To make programming faster, Spark provides clean, concise APIs like Scala, Java, Python, and interactively from the Scala and Python cells to rapidly query big data sets. How to run Spark? Local multi-core, just a library into your program and it runs. Secondly, it can be run from Amazon EC2. Yes, Amazon Web Service provides the support of Spark. Standalone deploy mode. Launch a standalone cluster quickly without the third-party cluster manager, and you can quickly trigger the queries in your cell. Running Spark on Mesos, running Spark on Yarn. Spark abstraction. This is the main part of one of the main part of a Spark. This is abstraction would be in RDD and a shared variables manner. So RDD is a resilient distributed data set. So RDD is a collection of elements partitioned across the nodes of the cluster that can be operated on in parallel, and RDDs are created by starting with a file in Hadoop file system or any other Hadoop supported file system, or an existing Scala collection in a driver program and transforming it. User may also ask Spark to persist an RDD in memory, allowing it to be reused efficiently across parallel operations. RDD automatically recover from node failures, and there are currently two types of RDD: parallelized collection and Hadoop data sets. Other part of abstraction is shared variables. Shared variables can be used in parallel operations, and by default Spark runs a function in parallel as a set of tasks on different nodes. It ships a copy of each variable used in function to each task. Sometimes a variable needs to be shared across tasks or between tasks and the driver program. Here are two types of shared variable: broadcast variables and accumulators. This is the Spark framework. It's very similar with the Hadoop framework. The difference is that in the Hadoop framework we never ever talk about the RAM, but here that is the main part. Here it's an example for mining console logs. So if you see a lines spark.txt file, you can have the local file system or HDFS or S3 over there, and it is the base RDD and it becomes the transform RDD, and in same behavior of Hadoop like worker and driver, but with the implementation of cache. So here is the result, that 1 TB data in 5 to 7 seconds instead of 170 seconds for on disk data. Here is the another example of logistic regression, and here is the performance for logistic regression comparing with Hadoop and Spark, running time in seconds and running on iterations. This is a word count example, a very famous big data analytics word count example for map and reduce. And here is a standalone job in Java. Running Spark on EC2 is very easy, I would say, and here is some of the gist of that, and Amazon Web Service address where you can find more details on that. Behavior with not having enough frame. So see the difference between fully cached and cache disabled. So it is required that the machine should have a good amount of frame. And here is the tuning part of Spark. So tuning is important. There are many tunings required in Spark, and one of the tuning which is required is memory tuning. Other one of that can be data serialization. So here for memory tuning, the amount of memory used by your objects matters, the cost of accessing those objects matters, the overhead of the garbage collection matters, and this is one of the statistics that how Java objects can be reduced by Spark and getting some lesser bytes on it. Here are the framework built on Spark, Pregel on Spark Bagel. Google messaging passes the model of graph computations at less than 200 lines of code, I think so, for Pregel. And here is the Hive on Spark, the Shark. The Spark applications could be in-memory data mining on Hive data. Coniviva has implemented it. Predictive analysis, Quantified has implemented it. City traffic predictions, Mobile Millennium has implemented it. Winter spam and collaborative filtration via matrix factorization. Here is a Conviva Geo report. See the difference between Hive and Spark. It's a huge difference. The conclusion. So Spark provides a simple, efficient and powerful programming model for a wide range of apps. Fast in execution, lesser line of code, data set can be shared, an effective solution for programs like iterative algorithms and interactive data mining. You can download the Spark from this websites. These are some references which can be useful, question and answers, and thank you so much for hearing me. Thanks.